Look in the mirror, and you will see a creature built on balance. From sharks to cheetahs to human beings, bilateral symmetry is the biological default for moving through three-dimensional space. A balanced frame manages gravity, sprints in a straight line, and outmaneuvers a predator. If one side of a cheetah's body was heavier or longer than the other, it simply wouldn't survive the first chase. We are so reliant on this physical balance that we subconsciously measure it in each other. Biologists measure this using fluctuating asymmetry, the tiny, random deviations away from perfect bilateral symmetry. Looking at this geometric overlay, you can see how we measure millimeter-level differences between the left and right sides of a face. We instinctively read these tiny deviations as a proxy for genetic health and developmental stability. Perfect symmetry is our ultimate signal for physical fitness. But the moment you break the surface of the skin, that perfection vanishes. Beneath the ribs, human anatomy completely abandons the pursuit of symmetry. This chest schematic highlights a lopsided layout. The right lung has 3 lobes, the left has 2, making room for an off-center heart. Panning down, the abdomen is even more erratic. A massive liver dominates the right side, physically forcing the right kidney lower. If perfect balance is the absolute biological standard for survival on the outside, why is the inside allowed to be such an unbalanced, chaotic mess? That internal chaos is actually a highly engineered solution to a strict packaging problem. And the most extreme example of this compromise is the gastrointestinal tract. A human adult relies on roughly 30 feet of intestines to absorb nutrients. If those organs were arranged in a perfectly straight, symmetrical line, a human being would have to be 3 stories tall. This structural diagram shows how evolution navigated the problem. To fit 30 feet of tubing into a compact, mobile torso, the body rapidly scrunches and folds it into an asymmetrical mass. The need for space destroys any possibility of symmetry. Fetal development works a lot like twisting a balloon animal. Organs actually start out perfectly symmetrical in the early embryo, but they must contort and rotate to fit inside their cramped containers. Looking at the center of this chest cavity, you can see how the heart begins as a simple, straight vertical tube. As it grows, it runs out of vertical room, forcing it to fold in on itself and twist into an off-center, 4-chambered pump. Internal asymmetry is the biological price we pay for mobility. It allows massive, highly complex organ systems to fit securely inside a streamlined aerodynamic shell. With so much dense twisting and packing, the organs run a high risk of getting fatally tangled. The embryo needs a way to guarantee every organ folds in the exact same direction every single time. The directors of this process are microscopic. These are cilia, tiny, hair-like biological motors lining the embryo during the first few weeks of development. These cilia beat in a synchronized rhythm, acting like oars to sweep surrounding embryonic fluid to one specific side of the body. This graphic shows those fluid particles being swept to the left side of a central node. That physical current breaks the initial symmetry, triggering specific genes, like the Sonic Hedgehog gene, to map out the left-right axis and tell the organs exactly where to position themselves. The dense layout of our chest and abdomen is directed entirely by the synchronized physical movement of microscopic hairs. When that microscopic machinery breaks down, we see the exact limits of how the body maps its own anatomy. This happens in a rare genetic condition called primary ciliary dyskinesia. If those cilia are paralyzed, they cannot create a directional fluid current. Without that physical cue, the embryo has no map. It has to rely on a literal 50-50 coin toss to decide which way the organs should fold. This split screen compares standard human placement on the left with what happens when that coin toss lands on the opposite side. The result is situs inversus, a completely mirrored internal anatomy, with the heart on the right and the liver on the left. This anomaly proves a critical rule of human development. The early body has no inherent concept of left or right. It only knows how to follow the flow of fluid. Because these mirrored organs still function normally, the structural condition is incredibly easy to miss. The underlying paralyzed cilia cause the actual medical issues, because the body uses those exact same hairs to clear mucus from the lungs and move eggs through fallopian tubes. Many people go decades without realizing their anatomy is backwards. They only discover it on an X-ray like this one, when seeking treatment for severe respiratory infections or infertility later in life. It brings us back to the stark difference between the face we present to the world and the machinery operating beneath it. Human beings are walking structural compromises. We require the illusion of perfect balance on the outside to run, hunt, and navigate our environment. But to fuel that external machine, we are entirely dependent on a chaotic, asymmetrical origami folded deep on the inside.